In section 4.5 we're going to work backwards. We're going to get a graph, and from the graph we're going to find the equation. So up on the board, just as a quick review, when we're finding the equation, there are actually 4 different values that we need to come up with. Just a real quick review, the first 2 numbers are the changes in y. The first one is the vertical shift or the midline. The second number represents the amplitude. The value between the trig function and the theta is the number of cycles in 360. We use that to find the period, and we take that number and divide 360 by that number. The horizontal shift is the last part. So let's go ahead. I'll give you an example, and your job will be to come up with the equation, all right? So here's my first graph, and I'm just going to do a real quick sketch of one here. And I'm not going to label everything. I'm going to tell you that the graph travels from -4 to 8 on the y-axis and 6 to 186 on the x-axis, all right? And so your job is to find those 4 values, all right? So first of all, I need the midline, and so if I go as high as 8 and as low as -4, the middle of 8 and 4 is 2. The way I got that was I added 8 plus -4 and divided by 2. Okay, from this midline of 2, I travel up 6 to the top and down 6 to the bottom. So the amplitude is 6. Right? It's clearly a cosine function because it starts up as opposed to starting on the midline. And then let's see, I'm going to go to the next easiest number, and that is because it starts 6 to the right. I'm going to put an x minus 6 here, and that leaves one more value. And to get this value here that stands for the number of cycles in 360, I'm going to find the period of this function by looking at the graph. And so 180 degrees is how far from the beginning of the cycle till the end, and 360 divided by 180 is 2. And so that's the equation of the sinusoid graph. Okay, let's do one more. Let's do one that has some fractions in it, and then we're going to do an application. All right, so this time, and I got to draw small because I didn't leave myself much room, right? And so we're going to start here and draw this graph. Oh, that's not very symmetric. That's better. All right, and so I'm going to tell you that we start on the x-axis at -80, and we end at 280, right? We get as high as 3 and as low as -6. So using that same process, the middle of -6 and 3 is 3/2, right? So we add -6 plus 3 and divide by 2, we get -3/2. So that would be our midline. Okay. Let's see, it's an upside down sign, so I'm going to put a minus in between the 2 of those. And from -3/2, I have to travel up 4.5 or 9/2 to get to the top. Now how I found that was I said if this is -3/2, right, I simply found the distance between 3 and -3/2 by subtracting. So 3 minus a -3/2 gives me a 9/2, which is what my amplitude is, all right? And so we said this was a sine curve, and we clearly have started 80 to the left, so I'm going to put an x plus 80. And then the last thing I need to do is figure out how many cycles in 360, and sure enough, we finally, this doesn't happen very often, but we do have that the period is 360. So when we divide 360 by 360, we get a 1. All right? And so we're going to practice a lot of those in class of finding the equations. All right, so let's go ahead and end this with an application. And so we're going to write an equation of a sinusoid that models a roller coaster, and we're going to pretend that it's a really boring roller coaster that does this. It keeps doing the same, and I know that most roller coasters don't do that, but we want it to be modeled by a sinusoid, so we're going to assume that it's just one that goes up and down the same distance each time. Okay, so with that being said, let's read the story and take the important parts out of it. So we get to a maximum height of 12 at 13.2 seconds. So the time when we get to 13.2 seconds, we get to the maximum height, which is 12 meters. So I'm going to put just a dot there, okay? And then when the time is 14.6 seconds, we hit the low point, which is 4 meters. All right? And that doesn't seem like enough, but because I've told you that it is a sinusoidal model, then we are guaranteed that whatever time this was that took us to get from the high to the low, then we're going to get right back to that high in the same amount of time. So let's subtract here, and we get 0.6 seconds, and so this would be at 15.2. This is the shape that our roller coaster takes. All right, and so now now that we've translated the words to an equation, the problem isn't any more difficult than the first two that we did. So let's go ahead and write y equals, the middle of 4 and 12 is 8, and then we're going to say that the amplitude from 8 we travel up to 12, up 4 to 12, down 4 to 4. It's clearly the cosine curve. We've started 13.2 to the right, so we write x minus 13.2. The only thing that's tricky at all is this number. And we remember that if we have the period, we can take 360 and divide by that period. And so the period is how long it takes to travel. Oh boy, I did really bad math here. I'm going to have to go back and change this. Ooh, please change that in your notes. I said that the difference between these two was 0.6 when it's clearly 0.4. And so from 13.2, oh, it's 1.4, right? I'm going to subtract here just to make sure. I don't want to mess this up. So 1.4 is halfway through the cycle, and so that means 1.4 later is 16. Okay, and so the period is the period in this function is 2.8, and 360 divided by 2.8 gives me a really messy number. 900 over 7. I don't like that at all. Whew. Okay, well, we're going to live with it. I promise in class we won't have such bad numbers. I really hope we don't. And I'm looking one more time to make sure I got the numbers in there right. Okay, I did. So there we go, our equation. In class, we'll practice this a lot. See you in class.